The universe. A word so simple, yet carrying within it a profound mystery. It's a word we use every day, but when we pause and truly reflect on its meaning, it's almost impossible to grasp. The universe encompasses everything. It's everything we know, everything we don't know, and everything that ever has been or will be. The stars, the galaxies, the dark expanses of space, the very fabric of reality itself. It is at once familiar and utterly alien, tangible yet unfathomable. And one question continues to linger, a question that has haunted humanity for centuries. How big is the universe, really? To begin understanding the universe, let's start with Earth. It's where everything we know, everything we hold dear, exists. Earth is our home, our cradle of life. We know every nook and cranny of it. Its mountains, oceans, and deserts. We've mapped every inch of its surface, studied every ecosystem, and explored nearly every corner of its atmosphere. Earth, in our experience, is everything. But when we zoom out, we see that Earth is just one small planet in a vast solar system. It orbits the Sun, a star among billions. Our solar system is a family of planets, moons, comets, and asteroids, all in motion, held together by gravity. Yet, as familiar as our solar system is to us, it's only a tiny fraction of the true scale of the cosmos. The Sun, while important to our existence, is just one star in the Milky Way galaxy. A galaxy so immense, its true size is difficult to wrap our minds around. The Milky Way is a vast spiral galaxy, a giant collection of over 200 billion stars. It's a swirling, spiral structure that stretches more than 100,000 light-years from one side to the other. To truly appreciate this size, imagine the speed of light, the fastest thing in the universe. Light travels at 186,000 miles per second, meaning it can travel around the Earth 7.5 times in just 1 second. Yet, even at that mind-boggling speed, it would take you 100,000 years to cross the Milky Way from end to end. To put it into perspective, our solar system is located in one of the galaxy's spiral arms, about 25,000 light-years from the galactic center. If our sun were the size of a basketball, the Milky Way would be about the size of the continental United States. In our solar system, it would be a speck of dust, a mere pinprick in this grand, galactic scale. But the Milky Way is not alone. It is part of a cosmic community of galaxies known as the Local Group. This is a small cluster of more than 50 galaxies, including the Andromeda Galaxy, the closest large galaxy to our own. But even this group of galaxies is just a tiny fraction of the observable universe. Beyond the Local Group lies the vastness of the universe. A universe made up of countless other galaxy clusters and superclusters, colossal structures composed of galaxies that are bound together by gravity. These superclusters stretch across hundreds of millions of light-years. One of the largest of these superclusters is Laniakea, a vast collection of galaxies that spans over 500 million light-years and contains over 100,000 galaxies, including our own Milky Way. The universe is not just a random scattering of stars and galaxies. It is intricately woven together by invisible threads. These threads are called filaments, vast, interconnected strands of dark matter that stretch across the cosmos. These filaments form a structure known as the cosmic web, a network of galaxies and galaxy clusters linked by dark matter. If you were to zoom out far enough, you would see a vast, intricate network, as if the universe were a giant web of galaxies, stars, and dark matter. At the intersection of these filaments are the galaxy clusters, while the voids, huge empty spaces between them, represent some of the largest and most mysterious regions of the universe. These voids are so immense that they can be hundreds of millions of light-years across, and yet they contain very few galaxies. It's as though the universe's structure is shaped by the gravitational pull of these filaments and voids, forming a web-like pattern that defines the layout of the cosmos. Now, let's talk about the observable universe. The observable universe is the portion of the universe we can see, measure, and study using telescopes and other tools. Its diameter is estimated to be around 93 billion light-years. 93 billion light-years. To put that into perspective, imagine light traveling across the vast expanse of space. Light moves at 186,000 miles per second, so in 1 year, it can travel approximately 5.88 trillion miles. If you could somehow travel at the speed of light, it would take you 93 billion years to travel across the observable universe. But here's the truly mind-bending part. The observable universe is only what we can see. It is limited by the distance that light has been able to travel in the 13.8 billion years since the Big Bang. However, this does not mean the universe ends where the observable universe ends. In fact, the universe could be vastly larger. It may stretch beyond the reach of our current observational tools, beyond what we can ever detect. Some scientists believe that the universe is infinite, an unending expanse that stretches far beyond our comprehension. But there's another surprising fact. The universe isn't just large, it's growing. Space itself is expanding. Galaxies are moving farther away from one another, not because they are traveling through space, but because the space between them is stretching. This phenomenon is known as cosmic expansion. It's as if the very fabric of space-time itself is stretching, causing galaxies to drift apart over time. This expansion was first discovered by astronomer Edwin Hubble in the early 20th century, when he observed that galaxies are moving away from us. More recently, astronomers discovered that not only is the universe expanding, but that expansion is accelerating. Something is causing the universe to stretch faster and faster over time. This mysterious force is called dark energy. Dark energy is one of the greatest mysteries of modern physics. It makes up about 68% of the total energy content of the universe, yet we know very little about it. It seems to be a repulsive force that counteracts gravity, causing the acceleration of the universe's expansion. Without dark energy, the universe would likely be slowing down or even contracting, but instead, it is growing at an ever-increasing pace. Dark energy is an enigma that challenges our understanding of the laws of nature, and its discovery has forced us to rethink everything we know about the universe. Now, imagine you could travel at the speed of light. It would take you 100,000 years to cross the Milky Way, 2 million years to reach the Andromeda Galaxy, and over 13 billion years to reach the most distant galaxies we know of. But even at the speed of light, there would be regions of the universe you could never reach. Some galaxies are moving away from us so quickly due to the expansion of space that their light will never reach us. These galaxies are forever beyond our grasp. And yet, even in the face of such vastness, we are driven to understand the universe. Every telescope, every observation, every mission into space brings us a step closer to unlocking its secrets. With each discovery, we peel back a little more of the cosmic veil, revealing more about the universe's past, its present, and its future. So, how big is the universe, really? It is bigger than we can measure, more complex than we can comprehend, and more beautiful than we can imagine. The universe is a mystery, a vast and ever-expanding frontier that invites us to explore, to wonder, and to dream. It is both a reminder of our own insignificance in the grand scheme of existence and a testament to our unyielding curiosity. And perhaps that's the most wondrous thing of all. The universe is not just a place to study. It is a source of awe, a boundless realm where the impossible becomes possible, and where every new discovery opens the door to even greater questions.